Hi, in this lecture and the coming ones we are going to talk about the concrete implementation for the Kosaraju strongly connected components algorithm. So I'm going to create several classes, the edges, the edge representing the edge in the graph. We will have the vertices, and I'm going to create a class for the graph itself. So what about the edge? Of course, the edge is going to have a private double weight. It's going to store a reference to the starting vertex, and it's going to store a reference to the target vertex. Okay. We are able to generate the constructor with the help of Eclipse, generate constructor using fields, weight, start vertex, and end vertex. Okay. Then I would like to generate getters and setters for all of the field variables, start vertex, target vertex, and weight. And basically that's all about the edge class. Okay, what about the vertex class? We are going to have a private integer ID. We are going to have a private string name. We are going to assign a name to every single vertex in the graph. We are going to have a private boolean visited flag to be able to check whether we have visited that given vertex in the graph or not. We are going to have a list of vertices, the adjacencies. Okay, of course we have to import the java.util.list. And we are going to have an ID, the so-called component ID. So every single strongly connected component will have some ID, and all the vertices belonging to the same strongly connected component will have the same ID. So that's why we define this component ID. Okay, in the vertex constructor, I would like to have an integer ID and a string name. So this ID is equal to ID, this name is equal to the name. This .adjacencies list we have to instantiate it as a new array list, of course. And I think that we have to generate the getters and the setters, generate getters and setters for all of them. I'm not sure whether we are going to use them or not. And I'm going to override the toString method with the returned this.name. I will have a additional method, public void add neighbor with a vertex. Okay, and here we just add the adjacencies list that given vertex we have specified. So that's all about the vertex class. Okay, so far we have the edge and the vertex. Basically it's very similar to what we have been discussing so far in other chapters. Breadth first search, depth first search, shortest path algorithms, and so on. Here we just have to make sure that we have a component ID, because we are going to assign the same ID for the vertices belonging to the same strongly connected component. And the graph, of course, is going to have the vertices and the edges. So we will have a list of vertices, it is the vertex list. We will have the list of edges, edge list. In the constructor, okay, so we will have a default constructor, and I would like to generate a constructor, so source generate constructor using the vertex list and the edge list as well. Okay, of course we have to import the java.util.list. So java.util.list. Okay, we generate the getters and the setters, so generate getters and setters for the edge list and the vertex list. And what we need, what we have discussing in the theoretical section, that we need to transpose the given graph. What does it mean, transposing the graph? Basically revert the edges. So there's an edge pointing from A to B in the original graph, then in the transpose graph there's going to be an edge pointing from B to A. So we revert the direction of that given edge. So we will have a public it's going to return the graph get transposed graph. First of all, it's going to instantiate a transposed graph is equal to a new graph. Okay, then we will have a list of vertices, the so-called transposed vertex list is equal to a new array list. So we just have to consider the vertices and the edges, of course. So we iterate through the vertex in this vertex list, so the original vertex list. And we just have to add these vertices to the transposed vertex list. It's not going to change. Okay, the edges are going to change. So for edge in this dot edge list, we would like to add to the transposed vertex list dot get the transposed vertex list dot index of the edge dot get target vertex. Okay, and we add the neighbor as the edge dot get start vertex. Okay, so this is how we reverse the edges. So we have the transposed vertex list, we get that given vertex where the index is equal to the edge get target vertex, and we add the neighbor as the start vertex. So this is how we reverse, basically this is how we transpose that given graph. And then the transposed graph dot set vertex list, I would like to set the transposed vertex list. Maybe we don't need, by the way, the edges, so the edge list, because the vertices are just enough. So we are going to return with the transposed graph. Okay, and I guess that's all what we need for the graph. We are able to transpose the graph. We have the vertices and the edges. In the next video, we are going to implement the algorithm itself. Thanks for watching.